So now that we have our Bakery1 database and two different clients to access it with, we'll do some more complex select statements on it. And we'll look a bit more at the column types that we looked at briefly in show columns before. Now, a brief prerequisite note here, by the way, the segment assumes you're familiar with logical expressions in programming languages, the sort that are used in if statements or while loops. And if you're not familiar with code, you should first go through the logical expressions module that is supplied as a supplement to this course. It'll fill you in on the basics you need to understand SQL where clauses, which we'll be talking about in this lecture. With the Bakery1 database set up now, we can try out the single most common SQL statement, select. And this statement retrieves data from database tables in various ways, ranging from simple dumps of the entire table to selective prints of rows or combinations of rows that meet specific criteria. We'll start simple and work our way upward throughout the course. And I'll use MySQL because, well, I'm old-fashioned and it's simple. I may use Workbench in some of the later lectures. Feel free to follow along with any client you choose, but as always, do follow along and try out your in-lecture answers on a live database of your own. So I'll start MySQL here. And of course I need to use Bakery1, and that'll let me access the Bakery1 database. In Workbench, you get the same effect by clicking on the database that you want to work with. The simplest possible select statement looks like this. Select star from, and then some table name. And that can be any of the tables in the database. This retrieves the entire table content and displays it in a textual tabular form, at least in MySQL. Under Workbench, you get a sub-tab for each select that you run, showing its results. In the prior segment, I did such select statements for each of the 4 bakery tables and saw that in MySQL, they output the same contents as the text files we started with. And I'll do that here for customer, for instance. And please do this now in your database. Remember that each command ends with a semicolon, by the way, as we discussed earlier. And note that even though all the select statements in this lecture result in printed displays of the selected data, select is used more generally for any kind of database retrieval, as for instance by a program retrieving the data for analysis without necessarily displaying the retrieved data. Okay, so a database table can be viewed as comprising horizontal rows and vertical columns. And the select example we just did shows all columns from all rows of the table. But the command is called select because it lets you choose subsets of the columns and or subsets of the rows to retrieve. If you want a choosier select, use this syntax. Select and then indicate what columns you want after the select statement, and we'll maybe choose kind and flavor as an example. Any column choice from the table is allowed here, separated by commas, and in any order you like. And then you can also add where and a row test. And this is a logical condition indicating which rows to show. As we just saw, omitting the where clause altogether retrieves all the rows in the select from customer we did here. And putting a star for the column lists selects or retrieves all the columns. Now, for instance, this select statement here, where we have flavor, price, and kind flavor, and let's list price as well here, from product instead of customer, where, and then we'll put the condition price is greater than or equal to 10.0. This will list the kind and flavor and price for all products that are priced at $10 or greater. Yep. And we get a little unplanned learning opportunity here. This is the kind of response you get from MySQL if you have an error in your SQL statement, and the error in this case is a comma I accidentally put there instead of a decimal point. So I'll fix that. You'll see similar things whenever you are using SQL. And you just examine the SQL statement carefully that you wrote and see where you might have messed up in the way of a comma or other such syntax error. Now what I get is a list of the kind and flavor and price for all of the products that are more than $10 in cost. The where clause can include the usual gamut of logical operations, comparisons, parenthesized grouping that are available in any programming language. I could run down the exact syntax here, but as you might expect by now, I'll ask you to please look it up instead, and then answer some questions below. And of course, bookmark those references that you find useful. I've been writing SQL for 2 decades, and I still need to look up SQL syntax now and then. One hint, though, by the way, select is considered part of the DML subset of SQL, the data manipulation language subset, even though it doesn't technically manipulate data. And this matters if you're searching the MySQL docs, which will list select under DML. So question 1 for you. What are the 2 operators to do a logical AND in a SQL where clause? Remember I said it mimics all of the features you'd expect in a programming language, and that'll include and or and not and so forth. While you're at it, what are the operators for equal and for not equal? And the answers you should come up with, double ampersand or the word and, capital or lowercase, will work. And then you use a single equal, not an equal, as in some programming languages, a single equal for equality comparison, and either less and greater or not equal will do for inequality comparison. So if then I want, for instance, to choose a product whose price is greater than or equal to 10.0, but also not equal to, say, 11.95, that'll factor out our strawberry cake there, then this condition would do that for us. Or if I like, I can use exclamation point equal for the not equal, and the word and for the logic, and get the same effect. And question 2. How do I represent a string constant in SQL? For instance, to compare a column like flavor with a constant string like chocolate, maybe asking if the flavor is equal to chocolate. If you look that up, you'll find that you can enclose your string constants either in single or double quotes. Now, you've actually seen me do it, I think, before in single quotes, but let's make sure here. Single equals for equality comparison, and we'll put chocolate in double quotes, or if we like, single quotes. Either one works. So now let's go through a number of select statement exercises to be sure the basics are understood before we move on. For each question, write your solution and actually run it against Bakery 1, revising it until it's correct, and referring, of course, to the MySQL documentation on select when you need to. Question 3. Write a select statement that lists the product ID and price for all products that are either a tart or a cookie. You'll need to list specific columns in the select, and you'll have to write a where clause using a logical test, including a logical operator we didn't yet discuss, but which you should have encountered in your research. When you run your statement against the Bakery 1 database, you should get 17 results. And if you find it useful, you can look up many examples of select statements online to use as a model. So one appropriate solution, at least, to that would be this. Select ID and price from product where kind equals tart or kind equals cookie, and that or is the new operator that I referred to, and you can use either the double pipe for it or the keyword or. Either one works. And we get our 17 results there. So question 4. how about a select that lists the ID of Travis Esposito in the customers table? Don't list more than just that one ID. Part of the challenge is to narrow it down to just that one guy. And you should have come up with something like this. Select ID from customer where last name equals Esposito and first name equals Travis. Note that you need both tests since there are 2 Espositos and 2 Travises in the table. Either test alone would have produced 2 results, but this one produces just the one expected result. And to show you what I mean about the 2 results, apparently ID 3 and 8 are both Esposito last name. So question 5, extend the answer from question 3 to list all products that are priced over $3.50 and are also either a tart or a cookie. And while you're at it, list the price first and the ID second. And don't forget to consider operator precedence. And again, don't just write the select statement, run it against the Bakery1 database. You should get 3 results. So one reasonable answer would be this. I'm going to select price and then ID, so we list the price first, from product where the price is greater than 3.5 and then in parentheses, kind is tart or kind is cookie. And there's our 3 results. Now, importantly, we have to consider precedence in this case. If we write price is greater than 3.5 and kind equals tart or kind equals cookie without parentheses, do we mean this grouping where we're in effect asking for either a high-priced tart or a cookie of any price, or do we mean the other grouping where we're asking for a high-priced product that is either a tart or a cookie? The question asked for the latter, and to get that we must have the parentheses because in SQL, as in most programming languages, and has higher precedence than or, and thus the first grouping that we did would be assumed without parentheses. And we'd get a rather different result. Question 6. List the dates of all receipts from Travis Esposito. You may use his ID in your query. Recall that was number 3. In an upcoming segment, by the way, we'll show how to do this without explicitly using the ID. So one reasonable answer then would be this. Select purchase date from receipt for customer ID equals 3. And so we get all of Travis's receipts there. Now let's look at some variations on that query. First, note that the dates are not in chronological order. If you want data in sorted order, you can make a select query sort its outcome by the value of any column or even combinations of columns. To do this, add an order by clause after the where clause, like this. Running this select gets us the same data as before, but now sorted by order date. Remember, it's order by, not sort by. The terminology, again, is a little dated. And the order by cannot come before the where clause. Question 7. Do some research on select syntax again, and write a select query to show the receipt dates in decreasing order instead of increasing order. And to do that, all we have to do is add the keyword DESC for descending after the order by, and now we'll get them in descending order or reverse chronological order if you like. Now finally, here's a preview of the upcoming segment in which we'll write select queries that span several tables. I'll repeat the same query we just did, but without relying on the fact that Esposito's ID is 3. And this will actually take several lines to fit in on screen, so I'm not going to put my semicolon until I'm completely done. You can see I get a prompt for the next line. So I've got select purchase date from customer, comma, receipt. 2 tables where first name is Travis and last name is Esposito. And then the second half of this is and customer ID equals customer dot ID, ordered by purchase date descending, and we get the same result. This select statement draws from both customer and receipt, filtering to get the customer row for Travis Esposito, and then connecting that with matching rows of receipt by requiring that customer ID from receipt match customer dot ID from customer. The table name qualification of customer.id, by the way, is needed because there's also a receipt ID. So instead of specifying a customer ID of 3, we're specifying rows of receipt that link with rows of customer having first and last name Travis Esposito. A connection between 2 tables like this is called a join, and most SQL queries use one. We'll talk a lot more about joins in the upcoming lectures. We'll also look more closely at the data types that columns can have in later lectures, but let's do a brief review here. Repeating the show columns command that we did earlier in a prior lecture on product, and let's do one on receipt as well. We can see that the Bakery1 column types include integers, abbreviated int, a string or sequence of characters declared as a varchar, a date for purchase date, and a decimal or floating point value for price. As with program variables, a column's type indicates the sort of data the column can hold. A column of type int holds only integer values. One of type decimal can hold floating point values with digits to the right of the decimal point. A varchar holds any sequence of characters, for instance a name or a word or a sentence, and a date holds a day and a time. These represent the most common column types, but if you look at the documentation for column types, you'll find there are many subtle variations on the basic themes of integers, decimals, string, date, time, Boolean and untyped binary also. There are, for instance, about a half-dozen different flavors of integer. And for now, just knowing the basic categories is sufficient. We'll look more closely at all the different variations and on what those parenthesized numbers mean in a later segment. A brief note, by the way, on date columns, like when ordered, or purchase date. These are specialized types. They're not really strings, even though they are printed as a series of characters like we saw here in the purchase date listing. However, you can use strings to compare with date values and to set the value of a date column if you conform to the format seen in the outputs. So a comparison like the one I just added here, purchase date is less than 2007-10-20. That will work to test for purchase dates that are prior to October 20th, 2007, of which there are a fair number. And there are other allowed date and time formats, which we'll discuss later.